guys, this is your boy Lex, your personal passionate math solver. For now, I'm actually going to be your personal math teacher. Please don't forget to subscribe to my channel, like and share my videos with your friends and loved ones. In this video, we're going to talk about complex numbers. What is a complex number? Someone may ask. A complex number is a number that can be expressed in the form a plus bi, where a and b are actually real numbers, either a natural, of which one is an example, a rational of 0.2 with 2 recurring is another example, or a decimal such as 0.3, or an irrational number like e. And I is actually a solution to the equation s squared equal negative 1. That is to say, s equal plus or minus root 1. That is simply taking square root of both sides. So what I'm just trying to say is that a real number plus an imaginary number should actually give us a complex number, of which 2 plus 9i is actually a typical example, where 2 is a real part and 9i is the imaginary part. So what we learned in school wasn't right. This equation has no real roots, thus imaginary roots. That is to say, s squared equal negative 1, s equal plus or minus root of negative 1, that is taking square root of both sides, and then x equal plus or minus I. Since we said I is the solution to equation root of what? Negative 1. So that's the concept of imaginary numbers for you. But wait, we understood the concept of roots of negative 1. What about if you are given root of negative 9, root of negative 7, or root of negative 16? What are you going to do? So if you truly understood the concept from above, then this should be very easy for you to solve. So let's solve accordingly. Root of negative 9 should be equal to root of 9 times root of negative 1. But root of negative 1 is the same as I from above. So I know root of 9 is actually a perfect square, which will be 3i. Root of negative 7 also gives us root of 7i, and that of root of negative 16, which is a first root of 16 is actually a perfect square. So root of negative 16 should also give us 4i. We know that I to the power 0 is actually 1. This is because any number, either rational, irrational, natural, just any number to the power 0 should actually give us 1, or any alphabet to the power 0 is actually 1. And we also know that I to the power 1, or just I, is actually root of negative 1. So will I to the power 2 give us a negative value? That's what we don't know. So let's simplify. I to the power 2, using idea from indices, we can say we can express in the form of I to the power 1 times I to the power 1. So 1 plus 1 will give us 2 here, which is the same thing. But we actually know that I to the power 1 is actually root of negative 1. So I to the power 1 is root of negative 1 times root of negative 1. The root of negative 1 times root of negative 1 will actually give us negative 1. So what about I to the power 3? I to the power 3 use the same idea as the indices. So I to the power 2 times I to the power 3, and that will give us, I to the power 2 is I to the power 2 times I to the power 1. So I to the power 2 give us negative 1 here, and I to the power 1 is root of negative 1, which is the same as I. So times I, which gives us negative I. So this and that. So moving ahead, let's digest another one. We also know I to the power 4. Let's digest this. Will be I to the power 2 times I to the power 2. So 2 plus 2 gives us 4 here. Hope I'm right. But we know that I to the power 2 is negative 1. So negative 1 times negative 1 will actually give us 1. Let's adjust I to the power 5. I to the power 5 will give us I to the power 3 times I to the power 2, which will give us I to the power 3 give us negative I, and I to the power 2 give us negative 1. So that will give us an answer of what? I. So I think some of you might see the pattern by now, that every fourth power of I, the pattern repeats itself. Let me take that statement again. So I think some of you might see the pattern by now, that every fourth power of I, the pattern repeats itself. What I mean by that statement is that from our previous, or from the beginning, we saw that I to the power 0 gave us 1. I to the power, so 4 power, the power repeats itself. So you should know that I to the power 4 should also give us 1. You give us 1 here. I hope you're enjoying the video. But wait, what about addition and multiplication of complex numbers? That is what I'll cover in my next video. Watch out.